Hey, good morning class, and welcome to lesson 5.2.2. How are the properties related? Today you're going to learn about properties of logarithms. And so we're going to investigate this concept of operations that we can perform with logarithms. I will investigate the properties of logarithms and how they relate to the properties of exponents. Recall our definition of logarithms. The log base b of a equals x. Now remember, that's how it's read. Log base b of a equals x. Its inverse or equivalent expression is b, your base, raised to the value of x has to equal a. So there are three properties of logarithms, each corresponding, not surprisingly, to a property of exponents. When logarithms were first invented, tedious multi-digit multiplication steps were replaced by table lookups and simple addition because of properties of logarithms. Although calculators have made logarithm tables obsolete, logarithms continue to be one of the most useful functions in mathematics. Use graphic technology to generate the table below. Then work with your team to identify the pattern within the table. Be sure to extend your table far enough to confirm your pattern. You do not need to copy the entire table by hand, but recording useful values may be helpful to identify patterns. So what we're going to do is we're going to take values for x, 1, 2, 3, 4, 5, 6, 7, and 8, and then we're going to take log base 2 of x. Now, you're going to have to do this on your calculator. Those of you who have newer operating systems or newer calculators, you'll find that there is a base solver. Now, there's some difficulty in me referencing the calculator and bringing it into here. So what I'm going to do, I'm going to drop in a picture from my calculator. Now, if you take and push your math button and scroll down, again, this is on the newer operating systems or newer calculators, you'll see this log base. Go ahead, tap that, and then enter the log base 2 of 1. Now, we know that 2 raised to some power has to equal 1. That's what this statement right here is saying. And anything to the 0 power, so 2 to the 0 is going to be 1. So that's why I get 0 here. Now, you can use your calculator, this log base solver, or you can try to do this with some trial and error. Now, x is now 2, so I'm going to take the log base 2 of 2, which really means 2 to some power has to equal 2. Well, that some power, well, that has to be 1. Now let's try it with the next one. Log base 2 of 3. Now 2 to what power is going to equal 3? That's where using this log base statement, that could really help make this a little bit easier. The log base 2 of 3 comes out to be 1.58. What I'd like you to do is pause this and fill in the rest of these, and then come back and check your answers. Okay, welcome back. And you can see that the log base 2 of 4 is really asking 2 to what power equals 4. Well, that's 2. And the log base 2 of 5 is 2.32. Log base 2 of 6, 2.58. Log base 2 of 8, in other words, 2 to what power? It's going to give me 8. Well, that's 3. So we've just created our table for the log base 2 of x, where x takes on the values of 1 to 8. And we could keep going, but we've got way more properties to discover from this table than to just fill in a table. So now use the table you created and/or patterns you noticed to rewrite each expression as a single logarithm. Well, here's what I'm noticing. I know if I take the log base 2 of 2, which is 1, and I add that to log base 2 of 3, which is 1.58, that equals, let's rewrite that, 1.58, add those together, and I get 2.58, which that's also in our table. If we take a look at our table, 2.58, well, that is the log base 2 of 6. Let's try one more. Log base 2 of 3. I'm going to write this up here. That's 1.58 plus the log base 2 of 5, which is 2.32. If I add those together, 3.90, which, if I'm thinking about this, I could try to figure that out by using what I notice over here. That's 2, that's 3, that's 6. So if I'm adding two logs together with the same base, I have to multiply those values together. So over here, if I have a 3 and 5, maybe this would be equal to the log base 2 of 15. What you can do is go to your calculator and use that log base and just see if the log base 2 of 15 actually is 3.90. I think you'll find out that it is. Let's jump down and do D. Log base 2 of 15, which we just verified over here, is 3.90, minus the log base 2 of 3, which we know is 1.58, has to equal 2.32, which means if I take the log base 15 or minus the log base 2 of 3, what I'm really doing is taking the log base 2 of 15 divided by 3, which is really the log base 2 of 5. Because if the log base 2 of 3 plus the log base 2 of 5 up here is equal to the log base 2 of 15, well, if I subtract that from both sides, I should get the log base 2 of 3, or log base 2 of 5, excuse me. So, just thinking out loud, if I have the log base 2 of 12 minus the log base 2 of 6, what I really should get is the log base 2 of 12 divided by 6, which is the log base 2 of 2. So let's just try that out. The log base 2 of 12 is 3.58. Now I got that by using that log solver on my calculator, minus the log base 2 of 6, which is 2.58. And if I subtract those, I get 1. Well, 2 to what power gives me 2? 1. So what we've developed are a couple of properties. Here are your properties. If I have the log base 2 of A plus the log base 2 of B, that's the same as the log base 2 of A times B. And if I have the log base 2 of A minus the log base 2 of B, that's the same as the log base 2 of A divided by B. So do the patterns that we just identified work for logarithms in any base? Answer this question by having each member of your team choose a different base. Now, what you can do is go to your calculator and use that change of base function to do what I'm going to do right now. And you can use any base. It does want us to try it with different bases. I'm going to choose base 5. Maybe you want to choose base 3 or base 4 or base 10. And so I built my table with the idea of using 5 to different powers. So my thinking is 5 to the 0 power is 1, 5 to the first power is 5, 5 to the second power is 25, 5 to the third power is 125, so on and so forth. So go ahead, choose a base, build your table, or choose base 5 and build your table and then come back and check your answers. So just pause this and see if you can build your own table. Okay, welcome back. Now, using log base 5 of x, I'm just going to take this one right here as an example. I've got the log base 5 of 125. Let's rewrite that, 125. That's really saying 5 to what power equals 125? Well, that power has to be 3. If I was to take 15,625, this is asking the log base 5 of 15,625. That value I can find by taking 5 to some power has to equal 15,625. That power happens to be 6. So that's how I built my table. And all of these properties, or these two properties from above, do apply here. So let's examine this. We're going to take the log base 5 of 5 and add that to the log base 5 of 125. And if this property is true, then this has to equal the log base 5 of 5 times 125, which is 625. 5 times 125. Well, log base 5 of 625 is up here. And that happens to be 4. And the log base 5 of 5 is 1 plus log base 5 of 125 is 3. And yes, 4 does equal 4. Now let's try one with division. What if we have the log base 5 of 78,125 minus the log base 5 of 625? Does that equal the log base 5 of 78,125 divided by 625, which is 125? So this value, 78,125 divided by 625. Let's check this out. I'm going with the green highlighter. The log of 125 is 3. The log of 78,000, or log base 5 of 78,125 is 7, minus the log base 5 of 625, well, that's 4, and yes, 3 does equal 3. So our properties of adding 2 logs and subtracting 2 logs holds up for any base. What we'd like you to do is use these properties to help simplify or rewrite equivalent expressions. So I'll do the first one for you. Log of 2/3. An equivalent expression would be the log of 2 minus the log of 3. Now, you pause this and try the other 5, and then come back and check your answers. All right, welcome back. And here are your answers. You can take a look at them. Remember, anytime you are adding two logs together, you're going to multiply their values. Now, when I say their values, I'm talking about the value of 12 and the value of 5. Anytime you're dividing two logs, anytime you're subtracting two logs, you're going to divide those values. So go ahead, check your work, and pause it if you need to. Now for our final property of logarithms. Here's our table from earlier in the lesson. We are now going to take a look at a property of if I'm raising my x value to some power. Now I'm going to let that power be 2 here. How does that affect my table or affect the output? So in the first part, x is 1. So the log base 2 of 1 squared, well, 1 squared is just 1. And so now 2 to what power equals 1? Well, that's going to have to be the 0 power. Let's take a look at the next one. X is 2. Log base 2 of 2 squared. Well, 2 squared is 4. So I've got this 2 right here. 2 to what power equals 4? Well, that's got to be 2. Let's take a look at this next one. Log base 2 of x is 3 squared. That means 2 to what power is going to equal 9? And that exponent then is going to be 3.17 or 169. And let's do one more. Then we're going to see if we can find a pattern. X is 4. So the log base 2 of 4 squared means 2 to some power has to equal 4 squared, which is 16. Well, that's going to be 4, 2 to the 4th power. Oh, I'm starting to see a little something here. It looks like if I take this value times 2, take 1.58, take your calculators out, type in 1.58 times 2, and due to rounding, you get something pretty close to 3.16. So all I'm doing is each time I'm just multiplying by 2. And that happens to be what my exponent is. Try it right here. Take 2.32 times 2, and I get 4.64. Take 2.58 times 2. I get 5.16. And I'm just going to jump down here. 3 times 2 is 6. Now, again, where am I getting this times 2 piece? Times 2. Well, we're taking the log base 2 of x squared. And what we're really saying is that if I pull that 2 out in front, 2 times the log base 2 of x is the same as what we have up above. In other words, these are equal. So just as an example, I have x being 8, so the log base 2 of 8 squared, well, this is really asking 2 to what power equals 8 squared, which is 64. Well, that's going to be 2 to the 6th power. Go ahead, type it in your calculator. 2 caret 6, you're going to get 64. And isn't that the same as 2 times the log base 2 of 8? Because the log base 2 of 8 is 3. That's what we got right here. 3 times 2 gives us 6. So we've got this property. If n is any real number, what patterns do we notice? Well, just on this one example with base 2, we're noticing that the log base 2 of x raised to some power is probably equal to, or not probably, it is equal to n times the log base 2 of x. Now, I just want to verify that by going with a different base. So let's change colors. Let's go with green this time. And hopefully I can create some space here. If I fill in this table from the previous page, this happened to be 0, 1, 2, 3, 4, 5, 6, and 7. Now, with this idea of our property, if I want to find the log base 5 of x squared, what I could really do is take 2 times the log base 5 of x. That might be faster than trying to do all of that other work. So I'm really going to just take this top row and I'm going to multiply by 2. 0 times 2 is 0. 1 times 2, 2 times 2, 3 times 2 is 6, 8, 10, 12, and 14. Okay, so if you take and type these two equations in your calculator, and I've done that, I typed in the log, 1 minute, base 5 of x squared, and then 2 times the log base 5 of x, and you compare your tables, you'll see that given these values of 1, 5, 25, 125, 625, 3,125, and so on, our output is exactly the same. So these are equivalent expressions, and it really doesn't matter what the base is. The base can be 5, the base can be 2, the base can be e, and it really doesn't matter what the exponent is. So when we take this statement that we have over here, log base b of x to the n, that is equal to n times the log base b of x. Now this is what we call the power property of logs. And let's try this. So I'm going to do one of these, and then you can do the other three, and then come back and check your answers. Use tables that you created or patterns that we noticed to rewrite these expressions in two equivalent forms. So here's my expression, log base 7 of x, log base plus log base 7 of x. Well, if I have y plus y, that's 2y. If I have m plus m, that's 2m. So if I have log base 7 of x plus log base 7 of x, I have 2 log base 7 of x. But using that power property of logs, another equivalent expression is to pull that 2 out as an exponent for x. So I have the log base 7 of x squared. Using this as an example, pause this and you complete B, C, and D, and then come back and check your answers. Okay, welcome back. You can check your work. Let's talk about C first. In part C, we have 5 times the log of m. You can pull that 5 up as an exponent, so now you have the log of m to the 5th power. Now that 5 log of m can also be thought of, I have 5 log m's that I'm adding together. Log of m plus log of m plus log of m plus log of m plus the log of m. You can take a look at part D. Now B, remember this is ln. This is your natural logarithm. And so it's just another way to write log base e. That's equivalent to ln of some number. So we have the ln of a plus the ln of a plus ln of a plus the ln of a. That gives us 4 times the ln of a. Pull that 4 up as an exponent, and you have the ln of a to the 4th. Question number 57. Mr. Cooper decides to hold a contest with the students. He gives teams the following expression and tells them they have 1 minute to write as many equivalent expressions as they can. After 59 seconds, Maddie's and David's teams each have 6 expressions. So when David quickly adds 9 to his list, Mr. Cooper declares David's team wins. Mr. Cooper, Maddie exclaims as she rolls her eyes, you didn't even check to see if all the expressions were correct. What we want you to do is see which expressions are correct for both Maddie's team and David's team. You can highlight them, circle them, what have you. And then let's see which team wins. So pause this, go and highlight those that are equivalent to this expression up here. Log base 2 of 8 plus log base 2 of 8 plus log base 2 of 8. Make sure you pause this though. Don't just check my answers. So pause it and come back. All right, welcome back. And let's talk about expressions that happen to be equivalent, at least for Maddie's team. You can take a look. Maddie's going to clearly win. All of her expressions are equivalent to the statement up above. David's team, unfortunately, only 4 of his statements are equivalent. So let's take a look. If we have log base 2 of 8 plus log base 2 of 8 plus log base 2 of 8, obviously that's 3 log base 2 of 8s. Now, using the properties that we've worked with on the previous pages, I can pull that 3 up as an exponent, which means I now have log base 2 of 8 cubed. Well, take your calculator. What is 8 cubed? It happens to be 512. So these first 3 are all pretty straightforward from the statement that Mr. Cooper gave them. But now let's get a little bit more creative. 512. So log base 2 of 512. 512 is 1024 divided by 2. So that makes the next statement true. And when you divide this value in here, that's the same as, and this goes back a couple of slides, the log of the numerator, log base 2 of 1024, minus the log of the denominator, log base 2 of 2. So then that makes this statement true. So then where does the last statement come from? Well, that comes from back up here again. Think of it with this statement. We have the log base 2 of 8. That's really asking 2 to what power gives me 8? Well, that value happens to be 3. 2 cubed, 2 cubed gives me 8. So this is really 3 plus 3 plus 3. And that's why all of Maddie's statements, or her team statements, happen to be true. And you can go through and take a look at David's and kind of figure some of them out. He changed his approach a little bit in terms of his 2 to the 9th power comes from the 512. So if I was to take log base 2 of 512 and think of 512 as 2 to the 9th, so then I have log base 2 of 2 to the 9th, and that's where he built a lot of his answers off of. class, here are the properties that you studied. The product property of logs, the log base b of x times y is the log of the first factor plus the log of the second. Our quotient property of logs, log base b of x divided by y, is the log base b of the numerator minus log base b of the denominator. And then the power property, log base b of x to the n is the same as n times log base b of x. Hopefully you enjoyed the video. There is one more page if you want to do some practice on your own. So if you want to stop this, go work on your exit slips, your homework assignments. You can get that stuff done. If you want a little more practice, keep watching. Everybody have yourself a great day. All right, extra practice. Use your properties of logarithms to rewrite each of the following expressions. Use the calculator to verify your answers. We're not going to use the calculator. What you can do is use your property of logs to rewrite these expressions and then compare them to the answers. So if you want to pause this and then come back and check your answers, or if you want to watch one example, please do so. And then you can pause it and come back and check your answers. Okay, so in the first one, part A, I am taking and adding two logs together. So I have log base 10 of 5 times 7, which is the log base 10, or just log of 35. So if you want to pause this and do the rest of them on your own, please do so. B, adding, so that's the ln of 50 times 100, but then I got this minus 25 divided by 25, which comes out to be the ln of 200. Part C, I'm going to pull that exponent out in front. 3 log of 17. Part D, I am adding, so this is the ln of 4 to the 27th times 4. When you multiply like bases, add your exponents. This is the ln of 4 to the 28th power. E, I have a 2 out in front here. I'm going to pull that up as an exponent. So I'm going to start by rewriting this as log base 2 of m plus log base 2 of n squared. And when I'm adding logs of the same bases, I'm going to multiply these values together. So I have the log base 2 of m times n squared. And in the last one, we have subtraction. So I'm going to take the ln of a divided by b, and then plus c, so then that would be times c. Or another way to write it, the ln of a c divided by b. Now, this is the end of the video. Everybody go and enjoy your day. Please keep practicing your mathematical skills, and look for a video for next week on 5.2.3.